am DALILA binti RUSLAN, S50836. Today I would like to present my review paper entitled Decomposition Rate of Mangrove Avicenna Species Leaf, a Review. My supervisor is Associate Prof. Dr. Abahina Mustafa Kamal from Faculty of Fisheries and Food Science. For the introduction is, intertidal forest habitats in sheltered saline to brackish areas are mangrove. They are among the world's most active coastal habitats, restricted to tropical and subtropical areas, dominating approximately 75% of the world's 25 north to 24 south coastline and are estimated to cover an area of 1.7 to 2.0 multiplied by 10 km. The control factors affecting the rate of decomposition of litter are pH, environment temperature and humidity, chemical composition of litter and pH of soil microorganisms that affect the activity of cellulose enzyme produced by microorganisms such as litter decomposition fungi. Temperature is a physical parameter that affects the physiological properties of environmental microorganisms. Ecologically, mangrove acts as a nursery for the feeding, breeding and spawning of different aquatic biota. Mangroves also serve as a supplier of litter-derived organic materials so that the animals living in the surrounding water can provide nutrients. Litter is the dead material above ground which will undergo the process of decomposition and mineralization. In total, there are approximately 84 species of mangrove plants belonging to 24 genera and 60 families distributed worldwide, of which only 70 species are recorded as true mangrove and the remaining 40 as associated of mangrove. The sole mangrove genus that exists in the world is Avicennia. The genus of Avicennia contains a species of mangrove trees found in tropical, subtropical and temperate regions spanning in the globe, intertidal zone of estuaries and coasts. Microorganisms typically begin the initial decomposition of litter once leaf fall. Mangrove forests are hotspots of marine fungi for biodiversity. These fungi play a significant role in the food cycle and sustain the ecosystem of mangrove. The detritus-based significant fungi population of mangrove is involved in detritus production. Mangrove fungi decompose vegetative material and thereby enable secondary colonization by bacteria and yeast that further decompose the organic matter. As decomposer of the organic material, mangrove fungi serve as intermediaries for the flow of nutrients from organic matter to higher level. The decomposition of plant material is the mechanism in which organic compounds are physically broken down and converted into basic chemical substance that resulting in the creation of carbon dioxide, water and energy from which they are produced. For the problem statement, factors that cause the changes in decomposition of mangrove leaf is related to temperature, tidal inundation season wet and dry, rainfall and climate zone. For the objective is to review the decomposition rate of mangrove Avicennia species leaf. There are three methodologies. For the first is search strategy, which is Google Scholar, Science Direct, ResearchGate, and Springerly, and use keywords such as mangrove Avicennia species, decomposition rate, lithophore, microbiodegradation, and nutrient cycling. For the study selection is filter all duplicate article and journal by laptop software, read and study through the abstract, material, method, and result. And for the data reorganization and reporting, information seized from each study were organized particularly according to the data about species of mangrove Avicennia species, decomposition rate, method, and result in different climate regions. For the result and discussion, there are four mangrove species: Avicennia alba, Avicennia marina, Avicennia officinalis, and Avicennia lanata. This table shows the description of mangrove species. This table is show that decomposition rate of litter loss. This table 3 is show that decomposition rate in different climate zones with different mangrove Avicennia species. And the table 4 is decomposition constant by season wet and dry of Avicennia species by different of location. And table 5 is Avicennia species with different rainfall and tidal inundation by different habitat. For decomposition rate of litter loss, Avicennia officinalis show that for day 1, the litter loss is 79%, while for the Avicennia marina, for 115 days, the litter loss is 46%. Based on the table 3, decomposition rate of 95% of Avicennia marina for 357 days in New Zealand is the higher than Avicennia marina, 31.3% for 90 days in Indonesia. During the dry and wet season of Avicennia marina in Gobo estuaries is the highest decomposition rate of coastal compared to other Avicennia marina at different locations. At subtropical estuary coast, both Avicennia marina for tidal inundation is 20 days, while for rainfall of Avicennia marina is 172 mm for 56 days compared to Avicennia marina of rainfall 130 mm for 84 days. Non-chemical variables such as tidal height, rainfall, and temperature also affect decomposition. Decomposition develops more effectively in subtropical mangrove forests during the rainy season. It was found that with greater tidal inundation, faster decomposition of Avicennia marina occurs in lower intertidal areas. At low latitude, it also found that leaves decompose more efficiently. Furthermore, higher wet season temperature can increase microbial activity, increase little nutrient content, and enable rapid decomposition rate. And the last one is due to the elevated rainfall, soil moisture, and microbial load, there is a higher rate of litter decomposition and a rise in weight loss in the rainy season. For the conclusion is the rate of decomposition was related to the season with greater loss of litter during season. Rainy season that could promote the cycling of nutrients and support the estuary's food web by providing the subtropical coastal ecosystem with organic matter. And the last one is measurement of weight loss from the litter bed were the three most frequently used of litter decomposition in terrestrial environments since they represented the most efficient of the method. This is the references. And that's all from me. Thank you.